This is a question on applying the rules of the expectation and variance operator. Consider random variables x, y, z with x being equal to the sum of y and z. We're told that the expectation of y is 12. The expectation of z is 6. The variance of y is 2. The variance of z is 1. The covariance between z and y is a half. And we're asked to find a, the expectation of x, b, the variance of x. Note, in this question we're not told whether these random variables are discrete or continuous, and we're not told what their probability mass function or probability density function is, so we can't go and use the formulas for expectation. By that I mean we can't go computing this expression if x is discrete, or this expression if x is continuous. We can though use the rules of the expectation operator because we're told about the expectations of the components y and z that make up x. Okay, so I've restated the problem here. This is what we know. This is what I want to find. Now, applying the expectation rules, we know if we take the expectation of the left hand side to get what we want, we have to take the expectation of the right hand side, like so. Since the expectation is a linear operator, it means that we can take the expectation through the brackets acting on each term in this summation, like so. But we know what expected value of y is because we're told that it's 12, and we know the expected value of z, we're told that it's 6. So the answer is 12 plus 6 equals 18, and we're done. Okay, next part of the question, we want now the variance of x. Now x is made up of sum of two random variables, y plus z. So we can state variance of x is the same as saying the variance of y plus z. Now, how can we break down the variance of y plus z? Well, there is a formula that we learn in stats, and when I ask my students this in class, a few of them very eagerly say it's the variance of y plus the variance of z. And then I usually ask them, did you get that from a book? And they would say yes. And I would say, well, did you read carefully the wording above the formula or below the formula? Because this expression, variance of y plus z, is only equal to the variance of y plus the variance of z in a given condition. And the condition given in these introduction books is that y and z are independent. I prefer to teach my students, when they first see this, the most general formula, because otherwise they go and think that the variance of y and z is just the sum of the individual variances. This is the most general formula. Variance of y plus z is equal to the variance of y plus variance of z plus 2 times the covariance of y and z. Now, we're not going to talk today about what this covariance means, other than to say that if y and z are mutually independent, that means that the covariance is 0, and hence this disappears, and that's how you get the relationship that variance of y plus z is equal to the variance of y plus the variance of z. Now in this question, is the covariance 0? No, because we're told in the question that the covariance between y and z is a half. Right, the rest is simple because now we can substitute the values, and the answer is 4. The key point to come out of this question is that when you're looking at the variance of y plus z is the variance of y plus the variance of z plus 2 times the covariance of y and z. And if the covariance disappears, somewhere in the question or in the book it will usually say that y and z are independent of each other. But it's best to memorize it in the most general way. C. What's the answer to A and B if instead of x being equal to y plus z, x is equal to 1 plus y plus z? I've given you a hint here. We could use common sense. We don't need any calculations. Or we can use some algebra. I'm going to just use common sense. Okay, the expected value of x when x is equal to y plus z is 18. Now, if we have a 1 plus y plus z, think of it as shifting all the numbers up of x by 1. So what will happen to the expectation, the mean of x? You'd imagine that, using common sense, that will also shift up by 1. So the answer will be 19. Now, how about the variance of x? Variance of x when x is equal to y plus z is 4. Now, what happens when you add 1 onto y plus z? Well, we've already said that that means that all the points of x are shifted up 1. But recall that the variance of x measures how spread out the data points are from the mean. Well, if all the data points are shifted up by the same amount, does that influence the spread? The answer is no. So the variance will remain the same. For this and other material, go to our website statisticsmentor.com. To discuss this particular problem, click on the link below in the YouTube page.